Good morning, evening, or afternoon. How you doing today? Welcome back to Mr. Morrow's math class, Algebra 1 and 2. We are today going to learn how to divide polynomials. I am also going to add an extra step, something that's going to make your life easier. Not only am I going to teach you how to divide polynomials today, but I'm going to teach you how to divide polynomials using what's called synthetic division. So I'm going to show you both ways, long division and synthetic division, and they're very powerful tools that will be used later on, so we really got to memorize it and learn it. Before we do that, let's just have a brief review of the laws of exponents. When we multiply the same base here, as in a to the m times a to the n, that's going to equal a to the m plus n. You keep the base and you add the exponents, okay? So whenever you multiply the same base, you keep the base, add the exponents. When you raise a power to a power, whether you're raising just one term or two variables or a division, doesn't matter if it's a product, a single term, or a division, you are going to keep the base and you are going to multiply the exponents. You're going to distribute that outside exponent to every single thing inside of the parentheses, okay? So when you raise a power to the power, you keep the base, multiply the exponents. When we are dividing, when you are dividing the same base, you're going to keep the base and you're going to subtract the exponents, okay? Now remember, there's a couple ways to skin that cat. If I have x to the fourth over x to the third, that's of course 4 minus 1 is x to the first. But sometimes people get confused. If I have x to the third over x to the fourth, sometimes people will still say x to the first. And that's wrong. It's the first one minus the second one. So what this would really technically be is x to the 3 minus 4, which is x to the negative 1, which equals 1 over x. Now that's a pain. That's a lot of work to do. So instead, I taught you guys, you can simply eliminate. There's 3 x's in the numerator. Take 3 x's away from the denominator. I'm left with 1 over x. So division, same base, subtract the exponents. When you're dividing the same base, keep the base, subtract the exponents. Negative exponents. When you make a reciprocal, you're going to change the sign of the exponent. If I have a negative exponent in the numerator, I bring it down to the denominator to make it positive. If I have a negative exponent in the denominator, I bring it to the numerator to make it positive. If I have a quotient being raised to a negative exponent, I simplify the quotient first, then I reciprocate the quotient, and I turn the exponent into a positive. And anything to the 0 power is 1. Please remember though, if I have 2 to the 0, okay, that's 1. But if I have negative 2 to the 0, that's negative 1. Why? The 0 is only affecting the 2, and this negative is a negative 1 that is being multiplied to the 2 to the 0 power, so that's going to be negative 1. So hopefully that, gets the juices flowing in your brain, and we can focus on the next lesson. In order to properly divide a polynomial by a monomial, we're first going to divide polys by monomials. Remember, please, it's basically the distributive property of division. If I have a sum or if I have a polynomial, let's put it to you that way, in the numerator, and I am dividing it by one term, by a monomial, that monomial must be divided to every single term in the numerator. So a plus b over c is going to equal a divided by c plus b divided by c. Okay? That bottom monomial gets divided to every single term of the numerator. So for example, 12x to the 4th plus 24x cubed plus 4x squared divided by 4x squared. I'm going to divide 4x squared to every single term in the numerator. So that's going to leave me with 3x squared, right? What else? 24x cubed divided by 4x squared, 6x, and then plus 1. Done. Bye-bye. Have a good day. over. Pretty simple. For b, I'm going to divide 2a squared b squared to every single term in the numerator, giving me a squared 8a squared b cubed divided by b, a squared b squared is 4b. Very good. Minus, what's good? 3 over b. Very good. Because here the a's would cancel, but here 1b cancels the numerator, and you're left with 1b in the denominator. Very nicely done. I like that. That was great. And then last but not least, 5ab squared divided by 2a squared b squared. And hold on, I forgot the b over b here. Okay, and then this is plus 5 over 2a. Because the b's cancel and you have 1a left over. Pretty simple, right? Remember this, because next chapter we're going to start factoring. And factoring is kind of like dividing. So we're going to be doing what the easiest kind of factoring is called factoring the GCF, the greatest common factor. And we'll learn all of it, but this is the skill that is used when you factor something out. So remember this skill, guys. Does that make sense so far? All right, now let's get to the fun stuff. When we're dividing a polynomial by a binomial, remember basic division, okay? And follow the same procedures. Now, think about the procedures here. I know what I'm going to do is very simplistic. It's very baby, very second grade. Just remember the basics, and you're going to see how easy the tough stuff is. When I have 579 divided by 16, of course, 16 on the outside, 579. Again, I know you know how to do this. I'm just going through the motions to remind us the basics. I ask, how many times does 16 go into 57, right? Because it can't go into 5. So how many times does it go into 57? That's going to be 3, right? No, 4. Yeah, 3, which is 48. So bring down my 9, and then I'm going to have a 9. Okay, and 16 goes into 99 6 times, which is 96. And then I have 3 left over. Now I know that we know that at this point you would put a decimal and you would have a decimal answer. But I'm talking, we're going to go back to elementary. Back way in the day when you first did division, you would have a remainder of 3, correct? Let's analyze what we did here. We asked how many times does 16 go into 57? We said 3. We multiplied 3 times 16 and we subtracted the product of 48, correct? Then we subtracted. We have 99 left over. I dropped down what's next. 16 went into 99 6 times. I multiplied 6 times 16 and I subtracted the product, correct? I had nothing left to bring down, so I had a remainder of 3. Simple, right? Okay. Remember those procedures. Because I promise you're going to get a little freaked out here for a second, but please remember those procedures. I have x squared plus 10x plus 21 divided by x plus 7. So I'm going to have x plus 7 on the outside. And I have x squared, bless you, plus 10x plus 21 on the inside. I know this is a foreign concept. I know that you're going to have to change the way you think a little bit. Most people logically would say, okay, cool. I got to work with x plus 7. That's wrong. When you're dividing by a polynomial by a binomial, you're going to use the leading term. The leading term. And remember, the leading term is always a variable. It's never going to be a number. So the variable, the highest exponented variable, the leading term, must go in the front. So if they said here 7 plus x, you would still write it x plus 7. The variable, the highest degreed variable, always goes first, and that's who I'm going to work with. So for every single one of these questions that I'm going to pose to you now, we are simply working with the x. I promise you. You with me so far? So right now you only focus on the highest exponent variable. We cool? Okay. Now you're going to literally go one term at a time. One term. Don't worry about getting the whole entire thing done in one step. one term at a time. So how many times does x go into x squared? If x, very good. But if you don't know that, or if it's not that simple, on the side, just go, okay, what's x squared divided by x? That's x. So that's how many times x goes into x squared. Do you see that, guys? When it gets complicated, that's going to save you. Unless you can do it in your head, which is fine. With me so far? Now, didn't we multiply and then subtract the product? Do the same thing. Multiply x times x plus 7 and subtract the product. Okay, so x goes into x squared x times. So I'm going to take this x and multiply it to the sum of x plus 7. And I'm going to subtract the product. So x times x is x squared. X times 7 is plus 7x. Is everyone with me so far? Now, please, this is what gets most people. I'm subtracting this product. So I have to distribute this negative to everything inside of here. You with me? Yes? Okay, so this is going to become a positive. That becomes a negative. And that becomes a negative as well. Does everyone see what I did? I want to go step by step here. Okay, now, do you see how these first two terms cancel? If that does not happen, I'm sorry, but you messed up. There's no other way around it. If these first two terms do not cancel out, you messed up. Erase it, go back to the drawing board. I promise you, it's not a trick, or oh, he fooled me. No. If you do not cancel out that first term, you messed up, you chose wrong, poorly, do it again. So now let's continue subtracting. 10x minus 7x, that's 3x. And we always drop the next number down in regular division, 21. Now using the x, how many times does x go into 3x? 3 times. If you don't know why, go 3x divided by x. That equals 3. Now I'm going to distribute that 3 to the whole binomial and subtract the product. What's 3 times x? 3x. What's 3 times 7? 21. Now I'm going to distribute the negative, and in this case, the 3x's cancel out. They have to. And in this case, 21 minus 21 is 0. There's no remainder, so my answer is x plus 3. Yes, sir. Yes, of course you do like terms. 10x minus 7x is 3x. No, how could, no, it doesn't even make sense. Hold on. What are you talking about? Wait, I'm confused. You confused me. Hold on, let's just go step by step. Because you're confusing me, and if you're confusing me, you're confusing the class. Okay. How many times is x, now we're going to do it from the beginning. How many times does x go into x squared? X times. I'm going to multiply that times the binomial. Then I'm going to subtract the product. Then I'm going to distribute that negative. Then the first terms must cancel. Okay, they must cancel. They have to. If not, you messed up. Then, don't I add like terms? What's 10x minus 7x? 3x. I drop down the 21. You with me, my man? Now, how many times does x go into 3x? 3 times. Distribute it. Subtract the product. Distribute that negative. The 3x cancels. The 21s cancel. In this case, you have a 0 remainder. Does that make sense? Yes. Come again? No, it won't always be beautiful and pretty and cancel out. No. I've just done one example, guys. Let me breathe a little bit before you start bombarding me with all the potentials. Yes?
What do you do when you have the remainder?
Let me show you an example like I just finished saying. Let me breathe a little bit before you bombard me with the hypotheticals. Does everyone understand the basic procedure? Okay, now let's continue. So let's do it. We got 2x minus 1 into 6x squared plus 9x minus 10. Okay. How many times? First of all, we're working with the leading term. Okay, the leading term is the highest exponent variable. How many times does 2x go into 6x squared? Okay, I heard some people fidgeting. Worst case, you go x squared divided by 2x. How many times is 6x squared? How many times does 2x go into 6x squared, guys? 3x. So I have a 3x. I multiply that times my divisor, and I subtract the product. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. Now I am going to distribute the negative. My first terms must cancel. 9x plus 3x is 12x. I drop down my negative 10. How many times does 2x go into 12x? Positive 6 times. I'm going to multiply that 6 to the divisor and subtract the product. I'm going to distribute the negative. The first terms must cancel. Negative 10 plus 6 equals negative 4. Can 2x ever go into a number by itself? No. So that's my remainder. How do I write my remainder? I go plus the remainder over the divisor. And that's how you work it when you have a remainder. Does that make sense, gentlemen? I promise? Talk to me, that's why I asked. I just showed you. You have a remainder of negative 4. Can 2x go into negative 4? So you go plus the remainder over the divisor. Yes, sir.
You just leave it as a plus negative 4.
Correct. You do exactly what I said. You go plus a negative 4 over 2x minus 1. You do not do minus 4. Oh, you do not do that. Because you want to show the reader what was the remainder. And the remainder here was a negative 4. So you got to show that clearly. That's a very good question. Thank you. Talk to me, boys. All right, let's continue then to another one. First of all, is that in standard form the way they wrote it? No, right? And does anyone notice that there's a missing exponent? Very good. The fourth power is missing. So let me show you what happens there. Of course, you put your divisor on the outside. Now, when you're writing your dividend, you must go in standard form, and if you have a missing exponent, put a 0 coefficient. So I will have 5x to the 5th plus 0x to the 4th. You'll see why this is important. Plus 12x cubed plus 2x squared minus 9x plus 8. It looks intimidating, but it's not. How many times does x squared go into 5x to the 5th? Huh? 5x cubed. Very good. Subtract the product. 5x cubed times x squared is 5x to the 5th. 5x cubed times 3 is plus 15x cubed. Okay. I don't need my x to the 4th, but sometimes I do, and I like to align it properly. I distribute my negative. The 5x to the 5th and 5x to the 5th, they cancel. I can't combine my 0x to the 4th with anything, so don't worry about that. What's 12x cubed, though, minus 15x cubed? Negative 3x cubed. drop down the 2x squared. How many times does x squared go into negative 3x cubed? Negative 3x. Subtract the product. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative 3 is, oh, look at that, negative 9x. I love this. I love the way this one works out because it makes you think. Okay, so what happens here? I distribute the negative. The first term has to cancel. Can I add 2x squared and 9x? No. So I'm going to drop down my 2x squared. And what's negative 9x plus 9x? 0. How many times does x squared go into 2x squared? No, not 2x. Just 2 times. Subtract my product. 2 times x squared is 2x squared. 2 times 3 is 6. Distribute the negative. First terms must cancel. I have a negative 6 plus an 8, which is 2. And that's my remainder. So plus 2 over x squared plus 3. Long, tedious, but easy. Does that make sense, guys? Now, the good news is that there's an easier way. Yes, sir.
How do you get on the second step 3x squared if it's 0x to the fourth minus 1x to the third?
What?
On the second step, right?
Okay. You have 12x cubed minus 15x cubed is negative 3x cubed. And then I brought down my 2x squared. In this step, I can't add 2x squared and 9x. So 2x squared just dropped down. And then 9x plus 9x worked out to 0. And then at the end here, I had a negative 6 plus the 8 gave me a 2. Does that make sense? Yes?
If you move down the negative x,
What?
how would you move down the negative x?
Because I'm adding like terms. 9x minus 9x. Those are the only terms I can add together.
Well, aren't you adding?
I can't add a 2x squared to a 9x. So the 2x squared drops, and I combine the like terms. Negative 9x and 9x, which is 0. Yes, sir. Yeah, the x to the fourth did not have to combine with anybody, so I just got rid of it. That's 0. 0 times x to the fourth is 0. I just put it there because what if I did have an x to the fourth to combine? Then I can add them together, and I keep my alignment. Okay? All right. Now, synthetic division. You're going to love this a lot more. Synthetic division, you use this when the leading coefficient of the divisor is 1, though. That is the caveat. That is the warning. If I have a 3 here, you're out of luck. You got to go long ways. Because if not, you have a fraction, and then it's just a pain. You can do it still with synthetic. We're going to do it later on with fractions, but for right now, let's learn how to work with synthetic when your divisor has a coefficient of 1. So, what do? We're going to learn later on that this is going to become a root, which is a solution. So, what you do is you set the divisor equal to 0. So, x will equal 1 in this case. So, you put a 1 in a little backwards L. And then next to this little 1 with a backwards L, you're going to write all of the coefficients of the numerator, in standard form order. If I'm missing an exponent, I must put a 0. So x to the fourth has a coefficient of 1. Then there's a negative 2 for x cubed. There's a coefficient of 1 for x squared, a coefficient of 1 for x, and then you have a negative 1. Okay? Now, drop down the first coefficient of 1. Now, you take this guy in the backwards L, and what's 1 times 1? Put the 1 here, add it. What's negative 1 times 1? I mean, negative 2 plus 1. Negative 1. What's 1 times negative 1? Negative 1. What's 1 minus 1? 0. What's 1 times 0? 0. What's 1 plus 0? What's 1 times 1? And then I have 0 left over. Now, did everyone see what I did there? Okay, now, this here is going to be your answer. You look up at the first leading exponent that you have in the original problem. Do you notice how that had an exponent of 4? These down here are all of the coefficients starting with 1 less exponent. So your answer here is going to be x to the third, that's this one, then negative x squared, that's that coefficient, 0x, so we don't have an x, plus 1, and you have no remainder. And that's your answer. I'm sorry? Why would it be plus x? No. Let's go again. Thank you. I won't skip the step. Look, this is x cubed, right? Minus x squared. That's a 0. So if you want plus 0x plus 1, and this is the remainder, which is 0. So I can rewrite that as x cubed minus x squared plus 1. Okay? Let's look at the second one. I have negative 16x plus 70 plus x squared divided by negative 9 plus x. Yes?
Sorry, but like, how'd you get the x? You multiply those. How'd you get that x?
How did I get that answer? I already told you. You started with an x to the fourth. These are the coefficients of your answer, starting with 1 less exponent. So this is 1x cubed minus 1x squared plus 0x plus 1, and you have a remainder of 0. Okay. Thank you, son. God bless you. So first, let's rewrite this. This would be x minus 9. Set it equal to 0 to find my divisor. So I have my divisor, my backwards L. In standard form, my coefficients are 1, negative 16, and 70. Drop down my 1. 9 times 1 is 9. Negative 16 plus 9 is negative 7. 9 times negative 7 is negative 63. 7 is left over. My leading coefficient in the original problem was x squared. So I'm going to rewrite my coefficients with 1 less exponent. So this one translates into an x minus 7 plus a remainder of 7 over x minus 9. This is going to take time to practice. Come again? The more you do this, the more you understand. Okay? There was only one example left. Try this one on your own using synthetic division. All the other homework is valid. Check your Shobi and check your Edline because I put a 5-6 video online already. Thank you very much. Hope you learned a lot. Have a great day.